Hello, my name is Anton John Delmar, and this is my ECE 176 final project. So the aim of this project was to create an ASL translator. The motivation was because my sister, who's a speech language pathologist, brought to my attention the issue of auditory impairment. So children who maybe have speech impediments, or in this case, deaf children. So they need to use ASL, which is not very commonly used. So my project was to make a tool to help them communicate. For my method, I decided to implement four algorithms. So K nearest neighbor, a logistic regression, and then simple convolutional neural network, and an AlexNet. So I'll briefly explain the code. So the K nearest neighbor uses K equals 10 and then a batch size of 256. So it would take 256 images from each class, and there's 29 classes, one for each letter of the alphabet plus space, delete, and nothing. Um, okay, so we have the mean squared error, which just takes the difference between the image and the image in the data sets. And for predict label, we just see which label or which labels were the closest to the input image, uh, and that will be the predicted label. For the logistic regression, I use Torch NN module. So we learned about this in homework 5, and I used it because it was a very simple implementation. So we just have a linear layer and then the weights and the bias, and we flatten the image into a tensor and pass it to the linear layer. For the convolutional neural networks that I did two. So I made a simple three-layer one. It has two convolutional layers and one fully connected layer with ReLU activation. And I also use batch normalization because in the homework I learned that it helps generalize the features. Um, for the AlexNet, I did five convolutional layers and four fully connected layers, and also three max pooling because that's how the original AlexNet was implemented. I also use batch norm and ReLU for this one too. So for the results, so I trained it on a data set I found online through Kaggle. It, like I mentioned earlier, has 29 classes. The images are RGB, so three channel and 200 by 200. In the longer video, I explain the issues that I had with the online data sets that I found, as well as the custom data sets that I found. So I actually tried it with four data sets, and they all performed really well on data sets, but not on the live feed. So I'll just go ahead and continue talking about the code. So we input the libraries and load the models. We have the get device. So on Data Hub, we can use the GPU. We use Torch Vision's dset to load the images using the image folder class. It just lets you use the data loaders from Torch. For the train and test functions, I use the helper functions from homework assignment 5, which I hope is okay. Uh, and I modified it slightly so that we can plot the data at the end. So again, 29 classes, image size 200 by 3, 200 by 200 by 3. We load all the models, training and testing the models. So actually I trained or I tested the KNN in this one, sorry. So the KNN actually had an accuracy of 71%. And then for our logistic regression model, I trained it for 10 epochs with stochastic gradient descent with a learning rate of 0.01. And that will be the same for the CNN and the AlexNet, the three layer. So we got a 44% accuracy on the test set with 64% on the validation in the end. For our simple three-layer CNN, we had 88% on the test set and 90 on the validation. And for the AlexNet, we had 99 for both the test and validation, so pretty good. But as I mentioned before, there were some issues with the data sets, and it's a little hard to explain in a 5-minute video. So if you watch the longer 30-minute video, it'll be easier to understand why I had issues with actually making the model work with the live camera feed. So I'll briefly cover it. So I um, visualize the weights, and as we can see, it looks like the model learned the background of the images instead of the actual um, hand features. So if we take a quick look, so this was the data set I use, and as you can see, a lot of the images look the same. It's like a camera angle, and then they switch it up periodically. So it's not that good. I think this caused data leakage, meaning basically the training set and the test set were basically too similar. So there's too much like overfitting, and basically the model's already learning the test set while it's learning the training set since the images are way too similar. Um, Again, explained more in depth in uh, the 30-minute video. So I still decided to test the classification time. So here we have the same setup as before, loading the models, and Torch actually lets you save the models. So I trained everything on Data Hub with the GPU, and then I tested it here locally. So we just have, I had a target sentence, which was, hello, my name is Anton. Um, so the goal was to classify that. So to get the classification times, I simply just saw how long it took for it to classify the sentence and divided it by 22. And right here, we have this code that's commented out. It's adapted for the live video feed, so you can actually use CV video capture. But right now, it's using images in a folder to do it. So if we look at the reports, we will see the final results. So with our logistic regression, or sorry, we'll start with the KNN. The KNN took 19 seconds, giving it a 0.86 letter per second classification rate. The logistic regression model took 0.47 seconds, 0.047 seconds to classify with a 0.002 letter per second classification rate. The three-layer CNN took 5.76 seconds, so 0.26 letter per second. And finally, the AlexNet took 2.45 seconds, so a 0.11 letter per second. But as you can see, when they actually tried to write the sentence, the KNN got three letters right. The logistic regression sentence got none of the letters right. Uh, the the three-layer CNN also got nothing right, and the AlexNet got two letters right. So I would choose the AlexNet because it was the fastest while yielding the highest accuracy of 9%. And yeah, thank you. Let me just forget how to stop the recording.